let's talk about the law of cosines. The law of cosines is this fabulous equation that gives us a relationship between three sides of a triangle, of any triangle, and one of its angles. Now, if you notice, I did not draw a right triangle. So the law of cosines is one tool that allows us to find relationships in all triangles, not just right triangles. We're busting out of the confines of the right triangles today. Isn't that exciting? So, one thing you should know about this, lowercase letters in this context mean the sides of the triangle. Uppercase letters designate the angle. And the way it works, angle A is across from side A. The side across from angle B is side B. Again, lowercase letters for the sides. The side opposite angle C we call side C. So that's what this all means, okay? Now, often when people are first learning about the law of cosines, they say, okay, this is only going to work if I have a triangle named ABC and side A is always over here. Not so, okay? Really, I could write this as x squared equals, y squared plus z squared minus 2yz times the cosine of, what angle would have to go here? Yeah, angle x. That would be for some triangle xyz. The thing you have to know is that the side that goes here must be the side opposite whatever angle you have there. So don't get wed to the a squared being over there. Just remember that this is the side that is opposite the angle that you are working with. Side opposite the angle that you are working with. Okay? That's really the important thing to remember. These, of course, if you think of your commutative properties, doesn't matter what order you add those or multiply those. Let's see this in action, shall we? All right, so I will give you, we'll start with angle A. I don't know, that's looking smaller than 30 degrees. Let's call that 22 degrees. And let's say that side B, I'm just making this up, is 17 centimeters. Clearly, that's longer than 17 centimeters. But anyway, let's say side C is 11 centimeters. All right? And let's find the length of side A. All right? That's our mission. All right. Well, this law of cosines is going to help us. Okay, so I'm looking for side A. That's opposite, handily enough, my angle that's given. So I'm going to put A over on this side. Let's see if I can squeeze this in here. So I have A squared equals one of my sides plus the other side minus 2 times one of the sides times the other side times the cosine of 22 degrees. Alrighty? Hey, can I put that whole kit and caboodle into my calculator left to right? I think I can. Now, we are in degree mode, so make sure when you grab your calculator that you are in degree mode. And I'm just going to put this in. The calculator will follow the order of operations times the cosine of 22. Obviously, I'm going to get some weird irrational number. I get a squared equals 63.23323, blah, 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 blah. I'm going to take the square root. I don't have to worry about the negative square root because this is a side. And let's round to the nearest, well, it doesn't make sense to round to the nearest, let's round to the nearest whole number since I started with whole numbers. So A is about 8 centimeters. Okay? Plug and chug. That wasn't that bad, right? Okay, so what if I wanted to find an angle? What ingredients would I need to be given? So if you look here, there's room for 3 sides and 1 angle. So I'm thinking if I have 3 sides, I should be able to find an angle. Should we try that? All right, let's try a new triangle. And perhaps I won't even draw a triangle. I'll just say triangle tri has lengths, let's say T, side T is 10, side R is 15, and side I is, I don't know, 9. Okay? All right. And what angle shall we find? Let's find angle T, as in tsunami. Okay, so I want to find angle T. So angle T is going to go over here, which means side T has to go over here. All right, so here I go. I have not enough room. You know what? I'm going to write these like this. And I'm finding angle T. Okay. So side T has to go over here. So side T is 10. So I have 10 squared equals, I don't care which of the other sides, 15 squared plus 9 squared minus 2 times 15 times 9 times the cosine of T. All right, here I go. Now, can I put this whole kit and caboodle left to right into my calculator? You have to be careful. Order of operations, right? You can add these, but you cannot then subtract this because this is multiplied by the cosine of T. So what I'm going to do is I'm just going to subtract these away and say that's 10 squared minus 15 squared minus 9 squared equals all of that, just so I'm not tempted to break the order of operations. Okay, grab your calculators, everybody. Check my calculations. And of course, you don't have to write all of that out. Okay, I'm going to bring it up here, negative 206 on the left. And let's see, 2 times 15 times 9. I got negative 270 times the cosine of T over here. I'm solving for T, so I'm going to peel away the layers. Let's divide both sides by 270. That should give me some nice decimal here. I'm just going to write out the decimal now. Remember, whenever you're doing math, you never, never, never want to round in the middle of a problem, particularly in trig, because you'll get vastly different numbers. So keep your whole fraction, your whole decimal in your calculator. Hey, how am I going to find T? I know the cosine of this angle equals this ratio. How do I undo cosine? I undo cosine the way I undo any function. I take its inverse. Inverse cosine, arc cosine, however you want to write it, arc cosine of that ratio will give me my angle. So second cosine is on your calculator, and that gives me an angle of approximately 40 degrees if we're rounding to the nearest degree. Now wait a minute. Whenever I take the inverse cosine or inverse sine or inverse tangent when I'm solving equations, I often look for another solution, right? Is there another possible angle that T could be? Well, let's think. Cosine could be this positive ratio in the first quadrant, around 40 degrees. Cosine's also positive in my unit circle, right? In my fourth quadrant, well, wait a minute. That would be like 320 degrees. Clearly, you can't have an angle in a triangle that's 320 degrees. That would bust the bank. Okay? So I have found angle T. Okay? So play around with this. You have 4 ingredients, 3 sides, 1 angle. One thing for you to think about, 2 things for you to think about. What ingredients work? Can you be given any 2 sides and any angle and find the 3rd side? Play around with that. And a second thing to think about is, where did this come from? Looks like the Pythagorean theorem is involved. Try to derive this. Try to derive this. You know, if you're sitting around, some night you're bored, come up with a triangle. The only hint I'll give you is you want to drop an altitude. Play around with it and see if you can come up with the law of cosines yourself. All right, have fun.